Hi all, today's topic is binomial distribution for a problem 3. So in this question, it is known that the disks produced by a certain company are defective with a probability of 0.01 independently of each other. The company markets disks in a packet of 10 and offers a money back guarantee that at most one of the 10 disks is defective. What proportion of the disks are returned? If someone buys a 3 discs, what is the probability that he will return exactly one of them? So this is the question it is asked. So first one by one we'll go. So the probability has been given in the question to be p equal to 0.01. N it is given number of the packet is nothing but 10. It is asked to find at the most 1. At the most means we have to use a symbol to be less than or equal to. Probability of x less than or equal to 1 only we need to find. When P is known means Q I can calculate, it's nothing but 1 minus P. 1 minus P, 1 minus 0.01 is nothing but 0.99. So first we need to calculate probability of X is less than or equal to 1. So probability of X is less than or equal to 1 means probability of X equal to 0 plus 1 also. X equal to 1. Both we have to calculate. So first it is a binomial distribution. First I will write the formula for binomial distribution. P of x is nothing but ncx p power x q power n minus x where x equal to 0, 1, 2 etc. till n. So till 10. So 10cx p 0.01 the whole power x q it is 0.99 the whole power 10 minus x. So this is our p of x. Now substitute x equal to 0 in this and substitute x equal to 1. We get 2 answer. So p0 calculated. p0 when I calculate it 10c0 is 0 1 only. 10c0 is 1. Anything power 0. Okay. So 0.01 the whole power 0 also 1 only. So only I will be getting 10. So here 0.01 the whole power 0, 0.99 the whole power 10. So answer I will be getting 0.99 the whole power 10. Okay. So it is nothing but 0. Calculate in a calculator the whole power 10 when I calculate it I will be getting 0.90. Same way P1 when I calculate it, same procedure. So it is 10C1, 0.01 the whole power 1, 0.99 the whole 10 minus 1, 9. So calculate in a calculator, everything multiply in a calculator, we will be getting the answer 0.09. So two answer, add both the answer. So 0.904 plus 0.09, this is 904. So when I add it, I am getting 0.995. Okay, it is for only at the most one of the 10 discs is defective. Till here, the answer is x is less than or equal to 1. The answer for till here subdivisions only. So next proceed when I proceed it, what proportion of the disk are returned? So which proportion the disk is returned? Okay. So now what we have to do when it is returned? So the proportion of returned package nothing but 1 minus when I subtract it because this is not returned. Okay, not returned is 0.995. So how many proportion it is returned? So opposite 1 minus, when I subtract it, I will get. So 1 minus x is less than or equal to 1. Nothing but 1 minus 0.995. So it is 0.005 is my returned package. So completed. So next question, what it is asked in this? If someone buys 3 desk keys, okay. Now before it was 10 desk keys. Now if the question itself, they changing the question, but the same way, 3 desk keys only. What is the probability that he will return exactly one of them? Out of 3, one he is returning. So in that case, so now when I calculate it, so now when I calculate, so n, it is 3 disk, okay. So out of that, one returning k I'm taking, some other k I'm taking. It's to be 1 because already I used x. So I will get confusion same x if I use. So I'm using some other k, 1 it is written. The probability is same. It is not change. Same probability itself. New question it is asked. So n equal to when it is 3 disk and one of them is returned. Okay, so probability is same. So what is my returned exactly? So what is my answer? It is asked. So now when I calculate the same formula P of x only. So P of x, NCx, P power x, Q power n minus x is general term. Now according to our question you write. So NCk, P power k, Q power n minus k. Okay, so this is our question. Okay, so according to that, when I fix it, so it's 3c1 into p, it is 0.01, the whole power x k. It's okay, is 1. So 0.99, the whole power 3 minus 1. So it is nothing but 2. So now, so probability of returning 1 out of 3 only we are doing the calculation. It's nothing but this calculation. So 3c1 is 3 into 0.01 into 0.99 the whole square. So when I do a calculation, I will be getting 0.029. So this is my final answer for the last statement. So returned exactly 1. Exactly one of them. So the answer is 0.029. So third problem is completed. So our fourth problem. So fit the binomial distribution for the following data. So this is our fit binomial distribution. It's same formula binomial distribution only. We are going to fit it. Okay, so fit means how we have to do means, so binomial distribution, the formula only we have to use. The binomial distribution, we know that the formula is NCx P power x, Q power n minus x, where x is nothing but 0, 1, 2, etc. n. So it is P of x. Okay. This you remember the formula. So it is given, in the question is given, x is given in the question, frequency, f is nothing but, f is frequency, f is frequency. What is the use of fit? Okay, it may be a fit of binomial distribution or the next distribution coming in the video. It's a Poisson or exponential, any distribution. Fit, what it is nothing. What is the use of the fit means? So we have a frequency is given in the question. We can find a new frequency using whatever distribution given in the question. It may be a binomial or it may be a Poisson. So if the same question can be followed for a Poisson also. Same question can be followed for a normal distribution also. Same question can be followed for a some other distribution. So I can find a frequency, new frequency, that is called theoretical frequency. So new frequency I can find, but my answer, any distribution I use it, my total answer should be 80. Okay, only the number correspondingly x equal to 0 I am getting in the question 5. I will, when I use a binomial distribution, I will not get the same 5. I will get some other thing, but it will match. So when I add all the frequency, I should get the same 80. It is for a binomial distribution. Same question, if I follow, the frequency of each data will change, but the total will be the same only for a Poisson also. So only the corresponding distribution we have to change and we can find all the distribution we can use in a single question itself and find out the new frequency we can find. That is the use of the fit problem. Okay, so now I will tell what is the procedure to find it. Then before going with that, x and frequencies are given. So we need to multiply both x and f. We need to multiply it. That I will multiply it. So x is given in the question, f is given in the question. We have to multiply. So xf I will multiply it. X into f I have to multiply. I am writing the question as it is. Okay, this is our question. X 0 into 5. So that I have to multiply 0. 1 into 18, 18. 2 into 18, 56. 3 into 12. So it's nothing but 36. 4 into 7, 28. So 5 into 6, 30. So 6 into 4, 24. Calculate the total of XF. Okay, sum of XF, calculate it. This total you calculate it. 18, 56, 36. 28, 30, and 24. So I'm getting 192. Total is my 192. Already my F total already it is given in the question 80. 80. Okay. So both the total we have calculated. So what is the formula means? X bar is for mean. X bar means mean. So mean for normal x bar, the formula is sum of fx. It may be x into f or f into x. Both are same only when you multiply it. Divided by sum of the frequency. Okay. Sum of fx divided by sum of f is for a x bar. We know that binomial distribution means, everyone know that binomial distribution means, what is mean? Mean is nothing but NP. Already we know that mean means for a binomial distribution, the mean is NP. So equal to NP. Okay, I will, this both I will divide it. So x bar is nothing but NP equal to sum of xf is 192 divided by 80. Divide it. 192 divided by 80. You divide in a calculator. So 2.4. Getting a 2.4. X bar is 2.4. So now n, it is given in the question. It's not given directly. How it is given means, check in the table whatever the last term you have. Okay, don't include 0. Okay, don't write n equal to 7. 0, 1, 2 like this and all. You should not count. Last whatever. Okay, it may be a negative also. They may give in the question. That and all we should not bother. What is the last data given? That is my n. So this is my n. N given in the question to be 6. Okay. So n given in the question 6. Okay, now substitute 6p equal to 2.4. My p equal to 2.4 divided by 6. Divide it in a calculator. So when I divide it, 0.4. My p I am getting 0.4. P is 0.4 means q is nothing but 1 minus 0.4, 0.6. I know all the data. Now n I know 6, p I know it's 0.4, Q I know it's nothing but 0.6. All the data I know, I can calculate my new frequency. New frequency, the formula for new frequency, name for new frequency is theoretical frequency, because I'm going to use new frequency. So new frequency I have to use as a theoretical frequency, because already one frequency is the same f. If I use, you will get confusion, which is given in the question, which we have calculated. So I will use the name for that. It's nothing but theoretical frequency. So the formula for theoretical frequency, capital N into our binomial distribution formula. So NCX p power x q power n minus x, where x equal to 0, 1, 2, etc. small n. Okay, n is nothing but total number of the frequency. Total number of frequency. So it is given in the question to be 80. Okay, 80 into corresponding frequency. So it is 80 into the formula NCX p power x q power n minus x. I have to multiply. Put x equal to 0, 1, 2, etc. N is given to be 6. Why I told you have to use the last data. Now you check x equal to 0, you will get one answer. X equal to 1, you put, you get one answer. X equal to 6, you get your answer. It should match our table. Yes, correct. N is 6 only, it matches. But N 7 you take, it means it will not match our table. Additionally, one more table you have it. So that is why I am telling it is a wrong way. Okay, so you take N equal to 6 only. So now do the calculation in the table format itself. So we will do it in a table format. X is given in the question. Theoretical frequency. This is X. Our new frequency, theoretical frequency. Round off of theoretical frequency. This answer round off. Okay. X is given to be 0, 1, 2, 3, 4, 5, 6. Okay. Now put. Okay, so n, it is given in the question to be small n 6 cx p, already we have calculated 0.4 the whole power x, q already calculated 0.6 whole power n, so 6 minus x. So now substitute x equal to 0 in this. 0 you substitute means 80 into 6c0, 6c0 only, 6c0 it's 1. 6001, anything power 0 also 1. So 0.6 whole power 6 is my answer. So when x equal to 0, when I put, okay, so in the answer I will get, so 80 into 0.6 the whole power 6. Okay, you have to multiply in a calculator, we will be getting 3.73. Answer will be 3.73. That answer you have to write. Write it in a decimal itself. Okay. So now x is 1. You put the same x equal to 1. Rough work. This you can do it in a rough work. So 80 as it is. So 61 is 6 only. So 0.4 the whole power 1 into 0.6 whole power 6 minus 1, so 5. So this we have to calculate in a calculator. You calculate in a calculator, we will be getting the answer 14.93. I am getting the answer to be 14.93. Same way x equal to 2 you have to put, so 80 into 6 into 62. 62 you have to use in the calculator only. So x equal to 2, when I put, I'll be getting 80 into 62, 0.4 the whole squared into 0.6 the whole power 4. So this you do it in a calculator. Everything you multiply in a calculator will be getting answer 24.88. So my answer will be 24.88. So same way x equal to 3 I will be getting the answer 22.12. X equal to 4 I will be getting 11.06. X equal to 5 I am getting 2.95. So last answer 0.33. So this way I will be getting my answer. Okay, don't add everything. Okay, you add means it will not, 80 will not come. What we have to do it means round off this answer 3.73. Round off when I do it, it's 4. 14 point decimal and all, make it as integer number, round off 14.9, so 15. So 24.88, 25. So 22, 22 only. 11, 11 only. 2.953, 0.33 only 0. So add now all, I'll be getting 80. If I get 80, so your calculation part will be correct. You are done in the correct way. So this is the way we have to do it. Same thing we can do it for any distribution. It may be only you have to change the corresponding distribution, you have to change. So if it is a Poisson means change the corresponding Poisson distribution, we have to change it. The mean, it will not be NP, so lambda you will be getting. So this we will be seeing in my next video. Poisson distribution under the video, you can cross check it. Thank you.